Today we're starting chapter 11. We're going to be starting with areas of parallelograms. What I'd like you to do in your journal right now is I would like you to draw 3 different parallelograms. Okay? Just do your best to draw a parallelogram where opposite sides are parallel. So this side right here is going to be congruent to this side, and this side is congruent to this side. So draw that parallelogram. We'll put 11-1. We're dealing with the area of parallelograms. All right, I'd like you to draw another parallelogram, and then one more parallelogram. There we go. I'm going to do one more. All right, when you think of parallelograms, typically this is kind of what you think about, right? You got your typical parallelogram. Yeah. All right, so this right here is a rectangle. We have square right here. We have a rhombus. The board will wake up. I know it's the last period of the day. The board's kind of tired. It's worn out. It's just not wanting to work. I don't know why. It's not wanting to work. There we go. I had to knock a little sense into it.
Yeah, now it was well.
Right. All right. Still do it right again. So here we go. This is all. Oh, wow, it's being a little resistant. There we go. All right. So, if you hear ridiculous statements in the background and you're watching this video, that's what I have to deal with every day. Okay? They attempt to be funny when they're not, but they don't know any better. That's just high school students, so please forgive them, for they know not what they do. So, right here we have 4 different shapes, all parallelograms. Okay? A rectangle, a square, and a rhombus are all parallelograms. The formula for every single parallelogram, if you wanted to find the area, is simply the base times the height. Okay? That's the formula you're going to use for every single one of these. Now, in a rectangle, typically that's called length times width. That's what you're used to. Well, length times width is basically the base times the height. If you call this the length, you could also call it the base. If you call this the width, you could also call it the height. What you need to know about all heights and bases, they are always connected by right angles. If they're not connected by a right angle, then it's not a base, then it's not a height that are being connected, so you can't use it. Right here, a square, typically you think the area of a square, you will see, if you Google it, it will say S squared, which means side times side. Side times the side. But it still is the base times the height. In a square, the base and the height just happen to be the exact same measurement. Right? That's the base, that's the height, also known as the side times the side. It becomes very important. It's kind of hard to screw these up. I mean, you have to really work hard at messing these guys up, right? However, if you call this the base, this slanted length is not the height. The height is the straight up and down distance from one base to the other base. You have to figure out what this length is. This is called the height of this parallelogram. In a rhombus, you might call this side the base, but this side is not the height. The height, once again, has to be what? You have to draw it in somewhere. Draw it in where? Where it has to form what type of angle with the base? A right angle. That's what you need to know. All right? So this is the height of the rhombus. So the area of a rhombus is still base times height. Yes, you can also, in a rhombus, it's kind of cool, you can also do 1/2 diagonal 1 times diagonal 2. That's another cool little formula if you knew its diagonals. So for example, if I do the length of that diagonal, all right, and I do the length of this diagonal, now obviously I didn't draw a perfect rhombus, otherwise those would intersect at a 90-degree angle, so I didn't do a perfect rhombus, but if I did, diagonal 1 times diagonal 2 divided by 2, there would also be another formula you could write down in your journal and you could use. But this is obviously still what? The base times the height. So every time you see a parallelogram, you need to know you got to find the base, you got to find the height, and they have to be connected with the right angle. If they're not, then you're not going to find the area. Okay? So let's look at problem number 1. Problem number 1. We have a parallelogram. And it says we need to find the perimeter and the area. Well, the perimeter is pretty easy. What's the perimeter? All the sides, what? Added together. 30 plus 30 plus 20 plus 20. That's pretty easy. All right? That's 50. That's 50. Then you get a total of what? 100 centimeters. That's the easy part. If you mess up the perimeter, you're really working hard at not getting that right. Now, the area is a little bit trickier. The area, you have to find the base and multiply it to the height. Now let me explain something. You guys see this distance right there? I need that. I am going to call that length right there, I'm going to call it the height of the parallelogram. You're like, what are you talking about? That's not the height. Well, it sure is if you call this side the base. Don't always be so confined to this being the base. Don't confine your brain to that being the base. If I call this the base, then what am I going to have to do? I'm going to have to draw in a what? Another height, right? Well, if they already tell me, hey, right there, they already give that to me, then we can figure it out. Now, some of you already saw this and said, hey, this looks like a 30, 60, 90 right triangle. Well, you're right. This triangle right here that I'm shading in is a 30, 60, 90. Why am I throwing in problems that makes you know the 30, 60, 90? Because I actually want you to pass the final. All right? Because you know it's going to be on there. So we're going to write 30, 60, 90, x radical 3, 2x. So we're going to write all this down. We're going to practice it over and over and over again until it becomes second nature. Now, do you guys see that 30 centimeters? That is literally across from the 90-degree angle. So we'll put 30 right there. Do you guys see? That's 30. The shortest side is going to be 15. The side that's across from the 60-degree angle, which happens to be my height, is 15. Radical 3. So I'm going to highlight that part. That's okay. You can watch this video later and say, hey, so my bottle fell in the middle of class. It was awesome.
And then I explained.
And you got to explain that it was okay. No. Exactly. Now, everybody, what's the length of my base? You're right, it's 20. Good job. You recognize that opposite sides of a parallelogram have to be equal. All right, so if that's 20, that has to be 20. So right here, I'm going to say the area is 20 centimeters times the height, which is 15 radical 3 centimeters. Which gives us a total, if I wanted to find the exact number, I'd multiply the centimeters, but I'm going to call it centimeters squared. Just remember, area is always in square units. Okay? Area is always in square units. Now that will give you an approximate value. So we'll go to our calculator. Type in 300. Radical 3. Press enter and you get 519.6. So what I want you to do is write in 519.6 centimeters squared. Now what does a square centimeter look like? Alright? Imagine if you had a square that was a centimeter by a centimeter. This square right here is called 1 centimeter squared. So how many little square centimeters does this have inside of it? Pretty much close to 520 square centimeters is how many centimeters squared fill up that space. Okay. Now the only other problem we're going to do together today in class is we're not going to do the other 30, 60, 90 problem. We're going to go right down here and we're going to do a 45, 45, 90. So if you see a 45-degree angle here, that means this angle right here also has to be 45 degrees. All right, what we're going to do right here, this side has to be the same as this side. That side right there has to be the same as that side right there. All right, so we know that's 26 inches. And we also know that this is 22 inches. So if you wanted to find the perimeter, what would you do? Add all of those up together. All right? So basically, if you add them all up, you get a total of 96. Is that correct? That's 48. 48 times 2? Yeah, 96. So yeah. Add all those up, that's the perimeter. Area is a little bit trickier. What do we have to find? The base times the height. Okay. Now, the base, right here, is 26. That's the base. And we draw in the height. The height is this segment right there. That's the height. That's what we need to find. Okay. Now what kind of triangle are we dealing with? 45, 45, 90. So we're going to write 45, 45, 90, x, 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 radical 2. If you haven't seen the 45, 45, 90 triangle, I'm talking about this triangle right in here. This is the 45, 45, 90 right there. Now, what side was given to us? The side that was across from the 90-degree angle. So you're going to put a 22 right there. Now, there are 2 easy steps to go from a 90-degree side to your 45-degree side. There's 2 easy steps. Here's the 2 steps. You can go back to your journal and find them, or you can write them down right now. Step 1. Take half the hypotenuse. Step 2. Multiply that answer by a radical 2. What's half your hypotenuse? 11. Take that answer and multiply it by a radical 2. That's the length of your height. So 11 radical 2. So the area of this particular parallelogram, the area is equal to 26 inches multiplied by 11 radical 2 inches. That will give you your approximate value that you need in inches squared. So you have to take 26 multiplied by 11 radical 2. You get 404.5. So the correct answer the area of this parallelogram? It's 404.5 inches squared. That's your approximate value. What's the perimeter equal to? 96 inches. So there's your two examples. What are you always searching for with the parallelogram? Making sure you know what the base and the height are, and that they better be connected by a right angle.